Hello friends, today I will discuss the derivations to convert delta to star and star to delta in the circuits. Normally in the circuits, the elements are connected in series and parallel. But there are occasions where in addition to this series and parallel connection of elements, delta connected elements or star connected elements or both will be present. In such situations, it is not possible to simplify the circuit with the normal relations of series and parallel connection of elements. So it is necessary to convert those delta connected elements into star form or star form elements into delta connected system. So first let me discuss the derivation to convert delta to star. Delta elements are known and the equivalent star elements are not known. To get the equivalent star to this known delta connected system, here the elements are defined like this. In delta connected system, there are three terminals A, B, C. Between A and B, the resistor connected is RAB. The resistance connected between B and C is RBC. The resistance connected between A and C is RAC. And coming to the equivalent star, the terminals are three here A, B, C, and the elements connected to terminal A is RA. The element RB is connected to terminal B. RC element is connected to terminal C. And all these RA, RB, and RC the resistors are connected together at one point here to form the star connection. To know this RA, RB and RC in terms of the delta values which are known, we apply the general rules. So the equivalent resistance between the terminals and A and B is RAB is in parallel with RAC plus RBC. Here RAC and RBC are in series with respect to terminals A and B. Similarly, between terminals A and B, the resistors connected are in series, that is RA and RB, whereas RC is in hanging condition, so it can be neglected. Similarly, between terminals and B and C, the equivalent resistance in the delta is RBC is in parallel with the series resistors RAC and RAB. Similarly, in the star connected system between terminals B and C, the total resistance is RB plus RC, whereas RA is negligible as it is hanging condition. And similarly, between A and C in the delta connected system, the equivalent resistance is RAC is in parallel with RBC plus RAB. This RAB and RBC are in parallel with respect to terminals A and C. Similarly, here in the star connection also, the resistance between A and C is simply RA plus RC and RB is hanging condition, so it will be neglected. When we say this and this are equivalent, the resistance between A-B terminals in the delta must be equal to the resistance between A and B terminals in the star. Here, this is the terminal A and terminal C. A and C in the star connection. The equivalent resistance becomes RA plus RC. We write here like this. Then what is the equivalent resistance in the delta form here between A and C? RAC is in parallel with RBC and RAB. So we write RAC into RAB plus RBC because RAB and RBC are in series with respect to terminals A and C. And because they are in parallel, we write RAC into RAB plus RBC divided by RAB plus RBC plus RAC. Since we say these two are equivalent between terminals A and C, so RA plus RC must be equal to RAC into RAB plus RBC divided by RAB plus RBC plus RAC. And say this is equation 1. In a similar way, the equivalent resistance of star with respect to terminals A and B can be written in terms of the known delta values. So between A and B in the star connected system, the equivalent resistance is RA plus RB. Write it here. Similarly, in the delta connected system between A and B terminals, RAB is in parallel with RAC plus RBC as RAC and RBC are connected in series. So we add them. So RAB into RAC plus RBC divided by RAB plus RBC plus RAC. This is equal to, we call it equation 2. So this RA plus RB is the equivalent resistance in star, and this resistance is equivalent resistance between AB terminals of delta connected system. In a similar way, the resistance can be calculated for equivalent star between terminals B and C like this. So in the star connected system, RB and RC are connected in series, whereas RA is hanging condition, so it will be neglected. That must be equal to the equivalent resistance between terminals B and C in the delta form, that is RBC into RAB plus RAC divided by RAB plus RBC plus RAC. RAB and RAC are in series, so they are added like this, and this combination is in parallel like this, so the parallel combination equation will become like this. So let us say this is equation 3. Now subtracting equation 3 from equation 2, then we get a new equation called RA minus RC. So that is, to the right, we get the values like this: RAB into RAC plus RBC divided by RAB plus RBC plus RAC minus RBC into RAB plus RAC divided by RAB plus RBC plus RAC. Since denominator is common, take the denominator as common, then you simplify the numerator, that is RAB, RAC plus RAB, RBC minus RBC, RAB minus RBC, RAC. So it is observed that here some of the terms are going to get cancelled, that is RAB, RBC, here also RAB, RBC. This is positive whereas this is negative, so this and this going to get cancelled, and finally we get RAC common in the remaining terms. So then RAC into RAB minus RBC divided by RAB plus RBC plus RCA. Say this is equation 4. Now add equation 1 with equation 4. Then we get RC get cancelled, then we get 2RA is equal to, adding those right side terms of equation 1 and equation 4, we get like this: RAC into RAB plus RBC plus RAC into RAB minus RBC divided by RAB plus RBC plus RCA. After further expanding the numerator, we get RAC RAB plus RAC RBC plus RAC RAB minus RAC RBC divided by RAB plus RBC plus RCA. After further simplification, we get the term like this. This RAC RBC is negative. Similarly, there is a positive term here. This and this going to get cancelled. Then we get 2 RAC RAB divided by RAB plus RBC plus RCA. So transferring this, this 2 and this 2 going to get cancelled. So then RA will become RAC RAB divided by RAB plus RBC plus RCA. Say this is equation 5. So here the derivation is writing the equivalent star in terms of the known delta form. So the known delta form is this: RAB, RBC, RCA. So to write the or to get the RA, that is equivalent star, write here first simply RA. Then whatever letters are missing in ABC, we add each letter here to the suffix here. That is BC are missing. So here BC are missing. So B comes here. Similarly here C comes. So it can be easily remembered like RAB into RAC. Divide with the sum of the delta connected resistors, that is RAB, RBC and RCA, and say this is equation 5. In a similar fashion, we can also write the equivalent star in terms of the known delta values, that is RB is equal to, so denominator is as it is, RAB plus RBC plus RCA. In the numerator, first put RB, then besides that, whatever letters are missing here in ABC, so here B is there but AC is missing. So add that C here and A here. So then becomes RB value. So this is say equation 6. Similarly, RC value of star can be calculated like this: RAC into RBC divided by RAB plus RBC plus RCA. Say this is equation 7. So now let us derive. Suppose star values are known, delta values are not known, but we need to know what is delta value in terms of the star values. Now let us see how to convert a star connected system into delta connected system. So here star values of resistors are known, whereas delta connected resistor values are not known. To get those delta connected values in terms of the known values, we multiply these equations which are obtained while deriving delta to star values, so which are already obtained, that is equation 5, 6, 7. 5 means RA value, 6 means RB value, RC means 7 means RC value. So we multiply equation 5 with equation 6, then we add equation 6 multiplied with equation 7, then we add equation 7 multiplied with equation 5. So then simplify those, then we get like this. Equation 5 and 6 means it is nothing but RA equation and RB equation. So once we multiply left side, we get RA RB. Similarly, equation 6 and 7, that is RB RC. Similarly, equation 7 and 5, that is RC RA. And similarly, on right side also we multiply, then we add these terms, that is RAC RAB into RBC RAB divided by RAB plus RBC plus RCA into RAB plus RBC plus RCA. Similarly, next term is RBC RBA RAC RBC divided by RAB plus RBC plus RCA into RAB plus RBC plus RCA plus RAC RBC RAC RAB divided by RAB plus RBC plus RCA into RAB plus RBC plus RCA. So because numerator is common in all these right hand side terms, and that too it is a square, so we get like this: RAB plus RBC plus RCA whole square, and the numerator values here we get RAB, RAC, RBC, RAB. That is first term. Similarly, next term also we get RBC, RBA, RAC, RBC divided by RAB plus RBC plus RCA whole square plus RAC, RBC, RAC, RAB divided by RAB plus RBC plus RCA whole square. So after further simplification, we get like this. So here RAB means it becomes RAB square into RBC RAC. Similarly, next term here we will get RBC square into RAB into RAC plus next term here RAC is double time coming, so RAC square into RAB RBC divided by RAB plus RBC plus RCA whole square. And in the numerator RAB RBC RCA is common. So once it is taken as common, then we get here RAB plus RBC plus RCA divided by RAB plus RBC plus RCA whole square. If you observe here denominator in the numerator, one of the term in the denominator going to get cancelled with the numerator value. So that is this and this square going to get cancelled. Then we'll get RAB RBC RCA divided by RAB plus RBC plus RCA. So therefore, we write the final equation, that is RA/RB plus RB/RC plus RC/RA is equal to RAB/RBC/RCA divided by RAB plus RBC plus RCA, and say this is equation 8. And now divide this equation 8 with equation 5. So once divide it, then the left side we get RA/RB plus RB/RC plus RC/RA divided by RA. So on the right side we get RAB/RBC/RCA divided by RAB plus RBC plus RCA. That is as it is we are getting here this value, then into RAB plus RBC plus RCA divided by RAB into RCA. So from this, after simplification, we get RBC is equal to so here on the right hand side terms, so this denominator and this numerator going to get cancelled, and similarly that RAB RCA, this denominator RAB RCA going to get cancelled. We end up with only RBC on the right side, whereas left side is RA RB plus RBC RC plus RC RA. Then after rewriting this term, we get RBC is equal to this term. That is what we have written here. RBC is equal to RA RB plus RB RC plus RC RA divided by RA. So it can be observed that to get the equivalent to delta from the known star values, in the denominator put R suffix whatever letter is missing in ABC here, that missing letter put here as suffix, that is RA here. Here it is ABC, means BC is there but A is missing, so put here RA. And in the numerator, write the possible two terms products of known star values, that is RA RB plus RB RC plus RC RA. So we can easily remember delta value in terms of the known star values. Similarly, we can write the equivalent resistance of delta in terms of the known star values, that is RAB. So first in the denominator put R, and whatever letter is missing here, so ABC are the letters. So here AB is present but C is missing, so put that in the numerator R suffix, that is RC. Numerator is just RA, RB plus RB, RC plus RC, RA. Similarly, we can write the equivalent resistance in the delta with respect to terminals A and C, that is RAC, in terms of the known star values, that is equal to RAC is equal to, first in the denominator you write RB, because here AC letter is there but B is missing, so put that B here, that is RB. Then in the numerator whatever is written earlier like RA RB plus RB RC plus RC RA. So this way we can remember the equivalent delta in terms of the known star values, and also we have seen how to remember or calculate star values in terms of the known delta values.